Live, this is the Crew Lounge, where knowledgeable people come to discuss railroading and model railroading topics. Pull up a chair and let's get started.
All right, this is the TSG Live Crew Lounge. I'm John, your host, and today we're going to be talking about model railroading and technology, and how technology has changed model railroading, and how people use technology to enhance their model railroading hobby. So I have a great panel assembled today. I'm going to bring these guys in, and let's do it this way. I'm going to just bring everybody up, and I guess we can go one by one here. We can start with you, Bernhard, since you're the next person on the screen to my right.
Sure.
Welcome. Yeah, who are you and how do you use technology?
Hi, John. I'm Bernhard Beck. I'm based in San Jose, and I wanted, when I started this layout here that I'm sitting in at the moment, about 10 years ago, the thing I wanted to do is to have it run automatically. I wanted to see trains move, stop at signals, do the right thing, and I built it over time. Along the way, I learned that there is so much more to model railroading than seeing trains run on the layout automatically. But we can talk about, and we have talked about that, all those other things before. So that got me started. Building this got me really started in looking at technology, and it's been a lot of fun so far.
Awesome. Ray, how about you? Why don't you tell us a little bit about yourself?
I use technology in the area of sound effects in some of my buildings and lighting, and also battery power radio control for all the engines. I have an outdoor railroad, which is a dirty environment, and I could not see cleaning 1,200 feet of track every time I wanted to run a train. So when I first got started in outdoor model railroading, I used immediately battery and radio control.
Excellent. Something else we'll probably end up talking about, Ray, because I know a lot of people don't associate garden railroads with JMRI, but you use that as well with your garden railroad. So maybe we can talk about that sometime during our show as well.
Sure.
All right. John, you're next. People have seen you on the channel before. How you doing, man?
I'm doing well. Thanks, John. For me, technology outside of, DCC, which is pretty common, I started to do quite a bit with lighting buildings and integrating like Arduinos for effects. I've learned a lot on the web from that. And then also started working with a member of our club to do some signaling things, and also just running turnouts using JMRI and turnout lists and routes to make things a lot easier and have it all show up on the iPhone for people. So it's real easy for them to navigate the layout, especially when they're newer to what's going on.
Cool. And Seth, you have a business that's technology and model railroading.
Yeah, I do. Model railroad control systems. And it really grew out of, some things I had learned on my own layout. I am also a DCC, JMRI, CMRI, signaling, lots of buildings, lots of Arduino users. And a friend of mine and I created a company to build Arduino-based CMRI nodes. Then we expanded it to do telephone systems, which I'd kind of been doing anyway for people. We expanded that further to handle a variety of accessories, switch motors, controllers, switch machines, and a little RFID system. So yeah, I got my fingers into a lot of things.
Very good. So we're talking about technology in model railroading. And it's funny, I was thinking about this before the show, before we got started here, and thinking about how we're using technology right now to have this conversation, which is also a model railroad related thing. So we're already doing it and maybe not even thinking about it, taking that kind of for granted. But we can throw out something really broad to start our conversation, which is, what about DCC? It seems like something that was really instrumental in taking the hobby at a huge step forward You know what I mean? What do you guys think about that?
Well, I was at the Portland NMRA convention when the standard was approved, and there was a huge design review of everybody who'd been involved with it, for the last couple of years, and I came in a little late, but what they were trying to do, I think, was fantastic, and they've been extraordinarily successful. The idea was to have a standard on the rails of what you needed to tell a locomotive so it could respond. So you could bring your locomotives over to the club or to a friend's house, and within broad limits they would work fine. And that created a huge market, which enabled high volume production and some modern technologies to provide a very high quality, relatively inexpensive product. And we went from very basic 2-digit decoders to full 4-digit decoders with great consisting and great motor control, and then sound. And the latest generation of sound decoders is just awesome. And that couldn't have happened without making it available to everyone. So now everybody there, even people who know nothing about even Decoder Pro and probably won't program their own locomotive, can buy ready-to-run locomotives that have the right sounds for that locomotive. So it's fantastic.
Yeah, for sure.
And just like we're using a conferencing tool like StreamYard right now to talk about technology model railroading, and that is totally natural, totally normal. We're all used to cameras these days. Model railroaders are totally used to DCC, and that locomotives are making sounds. You have switching situations where train moves into a station, a switcher comes along, pulls some cars off the back, and goes somewhere. Doing that with DC, yeah, it's possible, but it's so much easier with DCC, and it's just normal now. You just take that for granted and don't even think about it anymore. How much technology actually is behind that to make that happen?
I think it was the specification that became a standard with the NMRA, and the certification that they did, and then getting all the manufacturers on board to support it. It created the critical mass that something like that needs to really grow in the industry.
I was going to say, just for us, I know, like at the club, John, DCC is what allows us to have multiple people run on the layout at the same time. Just because we have a large layout, but trying to do that in an analog fashion with blocks would be just insane. And from a COVID perspective, well, we haven't gotten to do it much. DCC would very much allows you to run a train all over the layout from a fixed point if you need to stay removed from everyone. At least in our situation, it does.
I hadn't even really thought about that angle.
Yeah.
Right. Okay, looks like we have our first question here. Let's see. With all the tech in DCC, we all run a main bus line for our track. So where do we get the power for switch machines, signals, and other additives? I've never heard them called that before on a layout. That's actually a good question. I don't really know that much about wiring, but I bet someone on this panel does.
Well, I think everyone does. Go ahead, Seth.
Well, I was going to say, most people run an auxiliary bus at 12 volts to run all the accessories. It certainly is possible to drive everything off the DCC bus, but the problem is that whenever you have a short anywhere, you knock everything on the layout down. So even if you're using DCC as your layout control bus, and I'm sure we'll come back to that later, you want a separate DCC circuit, at least on a separate breaker and preferably on a separate booster to run accessories. Otherwise, you're just continually getting yourself into trouble every time somebody runs a switch. But it's very, very common to see a 12-volt auxiliary bus.
Mm-hmm.
Don't some people run some accessories off of independent electrical, one other outlet too? Like I've seen these these little blocks that people plug in under the layout, and they plug it into their little house or whatever on the layout to light it up or something like that without having to run any wire. I mean, other than that one.
Yeah, we run a lot of that Woodland Scenics Just Plug lighting system, and those all have little plug-in, wall wart kind of things that run to power distribution blocks. Mm-hmm. Or for our Arduinos, we've used little, USB chargers because they only need 5 volts, and those typically plug into 110. Although I think even now we're trying to move towards taking the 12 volts, drop it to 5 volts, and then run that into the Arduinos because we're trying to eliminate all the random wall warts we have under the club layout because there's a lot.
Yeah, exactly. I mean, controlling them all at once becomes a real problem. I was going to wave a little board I made to do that, which, even comes with a voltage converter if you need it. But essentially what John said.
Yeah.
I would add on to what Seth was saying about, it's best, I think, to have a separate DCC bus for the track to run the trains, and the separate one for the switches to control the turnouts, and yet another one if you're going to control lighting and things. And that way, you have a layered approach where a short on the lighting system can't prevent you from running trains, and even a short on the turnout system can't prevent you from running trains once you get them set.
I've seen an interesting concept where a friend of mine, you guys have, and a few guys know Kevin Hill. He has a garden layout in Hollister, and they have different sound effects on the layout, and his are all run. It's kind of a simple thing. He puts like a little MP3 player or even a CD player inside a building.
Yeah,
just runs it off batteries all day. And
uses little computer speakers. Yeah, that's cool.
That works too. So there's a lot of different ways you can do that. I saw a question that came up that I thought was really cool. Look at this one. I think this is kind of an interesting idea. What's the next step going to be? What do you guys think?
I know there have been Bluetooth decoders and there have been Wi-Fi decoders. I don't know. They don't really seem to have gotten traction like other technologies. And LCC is great for a lot of things, but LCC isn't necessarily designed to run trains. I think it can, but I don't believe that was the intention, right? LCC was to be everything else. I know, Seth, you can speak quite a bit to this.
Yeah, I just didn't want to jump in first every time, but so a couple of things there. I was, working from the back forward, LCC was really designed to be a layout control bus. So for signals and switches, HMR animation, certainly the developers foresaw that they might do some other things with it. But I think you have to remember that for the first couple of years, NMRA was promoting it as unloading your DCC bus, which was presumably being swamped by too many DCC accessory decoders. I as a former network engineer, I find that a little hard to believe, but, without taking a deep dive into that argument, let's just say it was marketing hype. LCC is probably, not the right tool for the job, or not the best tool most of the time. What I think the problem with Bluetooth and Wi-Fi, although I frankly think it's really attractive, is just addressable market. People have become increasingly accustomed to being able to buy any locomotive ready to run with a DCC decoder. Now, if you're running a logging layout or a little industrial layout and all you need is one switcher or one shay, and the one switcher or the one shay has a Bluetooth or a Wi-Fi controller that's compatible, then fine. I mean, that's perfect. And in that case, one controller, one locomotive, there's no particular cost penalty. If you start having a dedicated controller and a dedicated locomotive for every locomotive on, say, a large operational layout modeling mainline, it's going to get very awkward. You got to keep track of 100 controllers for your 100 locomotives. They're not interchangeable, or at least probably not generally interchangeable. You have to hope that when Athearn comes out with the locomotive you want, it's compatible with the Wi-Fi system you bought because you loved it with your scale trains locomotive, or pick your favorite manufacturer. So I think that's holding it. On the other hand, if I were building a new switching layout or a small logging layout, or something along that line, I would find this very attractive.
And that goes back to the standardization argument you made earlier. I think DCC, it has such a large footprint at the moment that any change will both take a really long time and is not going to succeed unless standardized. And the efforts or the approaches where you just take most of the load off the track and use the track signal and the DCC signal only for running your trains and do all the other stuff on a separate bus, that works pretty well. Whether that separate bus is LocoNet or a separate DCC district running off a separate booster, or whether it's LCC or whatever, it doesn't really matter. But separating out the functions makes a big difference. And then you can go from there.
I'm kind of looking at the, oh, here we go. Oh, that's the one I was looking at. I don't know what MQTT is, but I bet someone on the panel does.
Oh, yeah. This is wonderful.
This is why we need Falkenburg. Yeah. All I know is it's a tiny wireless chip. Take it away, everyone else.
So MQ is a system that's a piece of software that's been around for years. And it was originally designed where you absolutely needed to make sure a message would get through. And the idea was you had a central server, is what we're calling it these days. And everybody who is producing events, a train occupied this block, or a push button was pressed on a fascia panel, that's registered with the central server. Then the signal that needs to change color, the switch that needs to throw, is constantly listening for changes on a particular block or a particular switch. This allows you to have a huge number of devices communicating with this central broker. Now, it can be done wired, but one of the beauties of this is that it's very well adapted to a new generation of inexpensive, it's kind of the next generation of Arduinos. ESP32 is the general term for the currently popular flavor of these, but the stuff just keeps getting better and cheaper. And these things, have Wi-Fi and Bluetooth on board. And it's very simple and lightweight. It's much less complex to implement than LCC, for example. Offers wonderful migration path for CMRI. The structure of the messages is pretty similar in a lot of ways. And I think it's very accessible to people who want to write their own code, while offering, huge advantages. So I think it's going to be one of the technologies to watch.
I see it used a lot in home automation as well. So when home automation is really, really cool, since they are you're going out of the special interest area and go into the mass market. And whenever that happens, prices come way down. Yes. And things get a lot cheaper. They get easier to use. There's standardized systems that you can plug into, and you don't have to buy special stuff for your model railroad anymore. You just use this normal standard thing that you just plug into an outlet, and it controls your whole house and your model railroad along the way. The event system that MQTT is using is similar to by idea to also how LCC is working. So events in LCC through a gateway into MQTT is totally possible. And I have not played with it, but that sounds super exciting.
Yeah, I mean, I think, let me just reinforce one thing Bernhard said about riding the cost curve of home automation. We're talking about a technology here where I think you find that certain large, well-known companies who are driving this, which would include like Cisco and IBM, they're probably each spending more money by noon every day than there is in the model railroad signaling market between now and the end of time. So, we are taking advantage of a vastly larger market to use this. And again, Hans-Rudi Tauner has done this little thing called Internet of Toy Trains. I don't think it's the complete MQTT implementation, but he's already demonstrated a native MQTT format, a gateway to LCC, a gateway to LocoNet. I've looked at gateways to CMRI. None of these, these are either here or not terribly difficult to do. So, I mean, this in many ways is a wonderful unifier of all existing hardware moving forward, while allowing them to all do what they do now.
Yeah, I'm going to have to learn more about this thing.
But how long until we don't have to write code for something like MQTT? Because I am not a code monkey. I need to plug it in and push the button and click the menu in JMRI, and that's it.
Well, the nice thing about it is JMRI already supports it, and it's basically form filling. So it looks, very much like any of the form-based stuff that you would use for your LocoNet accessories or your CMRI accessories. Yet it's event-based and has a whole lot of the, nicer, newer concepts that, LCC has, it being considerably newer than the two dominant standards, which are LocoNet and CMRI. So I think you get all those benefits and a fairly clean migration path in every case. So kind of neat.
So I took a quick look at the JMRI page. How do you run a turnout with MQTT? I mean, what goes between JMRI and moving the points, right? Besides the turnout motor, like how do you actually move the thing around?
Oh, there's a little, dongle that Hans-Rudi, for example, is selling one, and it basically looks like a memory stick. And then it uses typically Wi-Fi to communicate with a comparable device at the node, which is what all the turnouts and signals and fascia panels are plugged into. But you really have a sheet that says, well, here's my turnout number. Here are the events I'm doing. I'm open or closed. Here's my fascia panel and so on and so forth. And you just fill out some forms that tell you what you expect it to do when certain events happen. So it's not really coding, it's more form filling. You still need to understand what you want it to do. So if you knew nothing about signaling or had no concept of what you want to control, you still need to figure that out. But it's certainly not, like you and I would do with an Arduino and diving down into the C++. You don't need to do that.
Sure. You mentioned something in there that definitely has me curious, though. You started talking about wireless and controls and control panels. Can we build wireless control panels now? Because I have hardwired far too many control panels already, and I have not been a model railroader that long.
Yeah, totally.
And Bernhard, iPads at your club don't count.
Well, that's the future. Bernhard, talk about it. I think that's where we're going.
Yeah, we should take a small tangent on what John is referring to. So I'm also a member. Both me and Ray are members at Silicon Valley Lines, and what we have done a couple of years ago is we ripped out our hard panels where we have push buttons to line turnouts, and instead installed tablets. And the tablets are driving a web interface where you basically just on the tablet touch the turnout, and then a signal goes over to JMRI. JMRI talks to goes through the turnout table. Okay, this this button or that virtual button on the web panel refers to turnout number blah, toggles the turnout, sends that out to on the DCC bus, and or the switchet that is connected to that turnout picks up the signal and toggles the turnout. So it's a little bit a roundabout way, but it's this disconnect is what pretty much all the systems are using. You have some kind of input signal that you can think of as an event, and then you have another thing that responds to that input signal. And the only trick and the only difference between the various technologies is how do you get the signal from the input to the thing that is physically connected to the turnout motor. Everything else is like, the concept is the same.
Yes, but the is really not so clear to a lot of us, even those of us that do work in the Valley in technology, but still it's like, what is the voodoo?
so the one possibility is I cannot show this. The cable is too short, but I have a push button control panel at my layout here, and I'm not sure if you can see this. This one works the same way. These are all push buttons, but all they do is the push buttons toggle sensor inputs on a stationary decoder. And the stationary decoder is connected with LocoNet to the rest of the layout. So, and goes to JMRI. So all these things are doing they're sending sensor messages. And JMRI is interpreting that as this black button here is this turnout here. So whenever this sensor or this button is pressed, a sensor message shows up on the LocoNet, goes to JMRI, and JMRI knows this sensor means that I need to toggle this turnout. And so if I can take this panel and have only two cables going into it. One is LocoNet, and the other one is power for the stationary decoders, and that's it. So it's not completely wireless, but it's pretty close.
Thanks. I've implemented stuff like that at our club and in some other places. But so how do we get to the next step where it's just power, right? Since sometimes you run into limitations with LocoNet distances, the number of devices on there, or if you accidentally use Cat5 instead of the flat cable and it gets weird, things like that.
So now if you want to have this without a LocoNet, instead of feeding the sensor input into a LocoNet enabled stationary decoder, you feed the input into an MQTT enabled microcontroller, and that microcontroller sends the sensor message over Wi-Fi to another microcontroller that is connected somehow to JMRI, and then it continues the same way from there.
Do those devices exist yet, or is that something that's still being developed? Basically an MQTT box with 16 inputs or 8 inputs, you can plug a USB into, configure, and Bob's your uncle.
To my knowledge, those devices exist, but that's not it. Seth might know more about that than I do.
Hans-Rudi Tanner has done a couple of these, and as I say, he's got Internet of Toy Trains. It's worth a look. It's not, I would say it's more of a demonstration than a complete system, but it's getting fairly close. We have, as you probably are aware, a line of CMRI controllers where an Arduino plugs into a node that can handle anywhere between 16 and be expanded to 144 I/O lines, things that can read or control. Now I have prototype hardware where there is one of these ESP type controllers sitting on it, and that could very easily have an MQTT client on there, and that would turn your CMRI node into an MQTT node. Now, that is not something I can ship you today, but there is somebody actively working on it. So okay. I think that's something we like to be able to do, and I think the time frame is within a year. if we don't all go crazy once the pandemic ends.
Well, you might as well forget it, because we're all going to go crazy when the pandemic ends. Are you kidding me?
All of us old guys, one more shot and we're out of here.
I think what John
I'll join
was
you outside in 2022, right?
I think what John was hoping for was to be able to buy a tortoise with a little Wi-Fi chip in it, and it's all taken
Pretty
care of.
much. Power in, push buttons in. That's it.
Yeah, why not? I mean, there are tortoises with DCC decoders connected to them already. So sure, that's not that far away.
Yeah,
No,
it's just
ESP, frankly, is about the same cost as the decoder, so they should be pretty affordable.
Yeah,
it's just.
And
I have found
they're small.
The reduction in wiring alone makes it worth the cost usually.
Oh yeah.
Yeah.
Since I'm the only one foolish enough to volunteer to build these things for our club.
Now you can of course have a discussion there about, do you really want to trust your layout to all wireless controls? Maybe.
So, funny you bring that up, Bernhard.
When I looked under the layouts and looked at all the wires under there and realized there was no documentation for it, trouble.
Yeah.
I want to shift gears a little bit, if it's okay. Did you guys done beating this horse of the what is it, MQTT? Or is there more?
I had a different horse. It's related, but we can, if you want to move on to something else, John, that's cool.
Well, I know that it's kind of related tangentially to what we're talking about getting rid of wires and doing stuff remotely. And it has to do with Ray's remote controls for his wireless, because Ray's garden layout is completely wireless. It uses dead rail because he doesn't want to clean the, 1,000 feet of track or whatever it is. And I know that you have a little sort of presentation that we could put on the screen to talk about that. Just because, I think that, and again, it could be a completely different panel discussion. Garden railroading with wirelessly, I think could be a really cool discussion. But you want to bring that up, Ray, and kind of show us what you've done and the challenges that you had implementing that technology into your garden railroad? And John, if you could keep your other idea in the back of your head while Ray shows us this, because I don't know what it is.
Sure.
But it might be related. So let me bring up the screen here. Okay.
Let's see. Are you seeing it now?
Yes, we can see it now.
Okay. So this is my history of technology and development for my outdoor railroads starting around 1992. We were at that point, we were using radio control car systems, little cars that run around, and lead acid gel cell batteries, which are quite heavy. There were a lot of technical problems. We did sound by using little toy chips. Nobody was building stuff for railroads at that point. In '96, the first digital radio control by Loco Link, I believe, was issued, and Soundtrax came out with a system they called Sierra, which was not DCC. It was meant for single pin connections to control receivers for whistle, bell, steam exhaust, and blowdown, I think, with the four controls that you had from a transmitter. And then in 2009, so that's like a little over 10 years ago, Aristocraft brought out Revolution Unit, which was a fully bidirectional communication system with the train and your handheld throttle. A throttle looks a lot like the ones you see today for Digitrax or NCE. And lithium-ion batteries came out at that point, which were a vast improvement over the nickel-cadmium batteries that we had back then. And this is what a system looks like. In the upper left corner here of this boxcar is a local link receiver. There's the FM receiver and the throttle control unit. And then here's the Soundtrax unit. And these are D-cell acid batteries, basically gel cells. And that's what it took to put a system together back in the early 1990s. And then here's the Revolution system that I was talking about, the transmitter, pretty conventional looking thing, but bidirectional. It gets signals back from the engine as well. And in a tender here, the whole thing fits in a tender with this black thing here is the lithium ion batteries. And looking inside the tender, taking the batteries off, here again is the Soundtrax sound unit and the Aristocrat receiver. So things are getting somewhat smaller. One thing nice about outdoors is it allows you to use a pretty large speaker and get good sound, which you need outdoors because the sound dissipates pretty quickly. And yeah, then around the 2015s, I wanted to try and squeeze all this stuff into a tank engine, low 40. And I managed, that was kind of a challenge to myself. I managed to get it all into the cab. The speaker is up here in the roof. This is again the Soundtrax unit, smaller lithium ion battery system, and the receiver and engine controller right here from Aristocrat. About a year ago, I looked into dead rail for HO, and I found that there were a lot of people developing things, little one-man companies mostly. Some people were using Bluetooth, some people were using Wi-Fi, in a variety of different ways. Some of them required pairing with a single transmitter to a single engine. Others had more ability to control like DCC does, but they were using what's essentially cell phone size batteries. And I decided not to jump into that a year ago because there was still too much flux in the market with companies coming and going and trying out different approaches. I'm kind of waiting for something to gel and standardize and get to enough volume that there are companies willing to make this stuff. But it has the advantage, of course, of running on batteries is that you don't have to worry about frogs and you don't have to clean the track, which for a large layout would be pretty nice. And here's a closing shot. That is not a painted backdrop.
Yeah. I miss those days. All right. Well, thanks for that. I don't know where we're getting the echo from. Is that you, Seth? I know you dropped out for a second, but or maybe it was just the extra.
Hard to say. Can you hear me?
I can hear you now. It looks like Dave's chiming in about this.
Hey, look at that.
Thing. Yeah.
I think he's correct, but I think, certainly JMRI is moving rapidly, and we're going from one credible guy doing interesting stuff to a number of people being interested in doing it. You got to understand one thing with the control market in general is it's not huge. There's only at most a few hundred layouts a year, building new control systems, and a lot of them already have an investment from a previous layout. So, there's not going to be a huge critical mass where big brand name manufacturers are going to jump in, but you'll have, a lot of niche manufacturers who already support these communities, like Railroad Circuits in the Loco Net world, and or RR Circuits, Dick Bronson, myself, a few other folks, interested in doing that. And, later we'll maybe have a chance to talk a little bit about model railroad control systems in our business model. But I'm certainly hoping a lot of people who are just interested in doing it jump in with community contributions, because that's certainly a large part of what we support.
It's interesting to me how the effect of advancing technology, you were able, going back to the slideshow that Ray had, everything shrinks down, right? So it's probably going to be a while before N-Scale can go dead rail, but it looks like HO is not that far off. And it also sounds to me, sort of to tie it in with this I forgot what it is again. MQTT. Is that what it is? I should write it down so I don't forget. My short-term memory just sucks. But it sounds to me like that they're kind of related, because that MQTT thing has to be small in order for it to be, placed in areas on the layout for it to work without taking up a load of space, right?
Yeah, it doesn't require a lot of computing or communications power in today's world. For example, the server can run on a Raspberry Pi, and a fairly minimal one at that. The individual nodes, things being controlled or producing events, are on chips that are sub $5 and about the size of a postage stamp. So you can get them into a lot of places. Mm-hmm. And Dave is, raising a bunch of really valid questions, and maybe we should have another session on just MQTT. But, at the 10,000 foot level, most of the parts are already there. It just needs some standardization work on getting them to all talk to one another consistently.
Yeah, I don't know. We don't usually do this, and I don't know if he's able to. But Dave, if you're interested in calling in, I could send you the link to join us, even if you can't stay for long. I wanted to have him on as a regular panelist today, but he wasn't able to when we were starting up. Just let me know. Send me a text or something if you can, and we can get you. It's quicker than typing all this stuff in. So, but we can please continue the conversation. I mean, I'm kind of fascinated by this. I'd never heard of MQTT, so this is all new to me.
I mean, the whole home automation market is super hot right now. There are many things going on right now, and the general idea there is you put the technology into your light switches. So, for instance, or into your outlets. It's just everywhere. Into the lights up there. So that way you have this technology enabled house, and that of course is a much bigger market than model railroading. So what I said earlier is when you take these home automation components and use them for what they are designed for, but in the model railroading context, there is quite a bit of opportunity to bring down prices, to do things that you're likely not going to have in model railroading, because the market is so small as a special thing for model railroads. But you might as well just use that same technology that they use in home automation, similar to how many layouts use standard connectors from the automotive markets, or the remember the good old tail light bulbs for short detection. So now we're putting in PSX circuit breakers, but just flip the polarity automatically. But they work and they were very popular, the taillights, because they were so common in cars. Now many cars have LED backlights, and those bulbs are not nearly as cheap anymore as they used to be. So they're not actually economical anymore.
Right. Just like we can't get regular light bulbs.
Yeah, it's the size of the market that makes. Yeah, that's true. It's the size of the market that makes a huge difference in where the price point ends up being.
What's this, Seth?
This is what's called a Wemos, which is one of these processors that would typically be on the node, on the side of the tortoise, to use the earlier question I think John was asking. And you can see it's, the fat thumb, but that gives you an idea of what you're talking about. And you can buy this from your favorite Asian supplier for sub $5. So we're talking about that class of processor. So you can see that, even with markups and stuff, this is going to be comparable to a non-sound decoder in terms of price. So I think, the price threshold for ubiquity is certainly there.
I have a question. So that little chip you were just showing, the thumbnail chip, it's a processor and a receiver, both?
Yes, it's a processor with Wi-Fi on it. And it's got enough memory to do some real work.
Right, but just for something simple like throwing a switch, you could just put 2 wires into your switch, I guess, your switch motor, and then tell it somewhere else on the layout or in a different room wirelessly, hey, do your thing, and it'll take that and that's pretty cool. So that's what MQTT is. I didn't even know.
Okay. So here's a trivial application. I have a reverse loop, right? And I could certainly buy a reverser, but consider that maybe I have a sensor outside the loop that says, or 2 sensors, a train is approaching, and I figure out the direction. I know a train is approaching the loop. I send that as an event to the server. The turnout controller at the front of the loop says, oh, a train's coming. Better check and make sure I'm aligned for the incoming train, because I always run trains around the loop clockwise. Then once the train is clear and I have another set of optical detectors, coming around to the other side on the back of the switch that says, oh, well, a train has arrived and would like to come out. Well, let me check. Is there still an event, at the front, at the point end of the switch saying that somebody's there? No, there's not. Well, then I can throw the switch and I can align the polarity and, voila, now I've got an automated reverse controller. So, that's a little bit of a science project because there's plenty of good ways to do that today, but it gives you an example of what you could do with it and how you would make it work.
And here now you have lock detection, and those same lock detection sensors can drive the signals around that turnout. And you expand your science project into a signaling project. Yay!
It sounds like if you haven't already signed up for it, Bernhard, we're going to be talking about traffic control on an upcoming episode of this panel discussion. We could probably...
We all thought about signing up, John, but we figured it'd be the same talking heads every month.
Well, I understand that, but though, Seth, I don't have a problem with that. As long as the people are knowledgeable, it doesn't matter to me who they are. And besides, I like you guys. Okay, so someone's asking a question: are these designed for fixed home layouts or modular systems?
That's a great question.
Yeah, I'll let you guys take that. I think I know the answer, but go ahead, Bernhard.
I think I've been thinking about this mostly in the context of a home or a fixed home layout, but stuff like LCC for the wired context or MQTT for the wireless context works really well with modular setups as well, since they're fundamentally event-based. So the event doesn't care where the turnout is. All the intelligence is in that central broker that links the events together with the actions that need to happen. So if you do any of this in a modular setup, yeah, totally possible.
Yeah, our thought for that was to have essentially this little board which supports 16 things, and it can be expanded to as many as 144. Now, this little goodie executes CMRI, but again, we could have one with the other guy I just held up, and it would execute MQTT. And, the signals and the switches and all that stuff, they're the same no matter what control system you're using. And, migration would be as simple as that. And it would certainly be, very convenient with a small controller like this to put one on each module. And again, because they're so inexpensive and we're leveraging all this technology that's been developed for home automation, it becomes very affordable, even in a modular context.
I like this concept of sort of hijacking other technology and using it for your own application. I think that's a pretty clever process.
Very, very viral. Take
Yeah.
over the machinery of the other system.
It's a clever idea, though. Let's see what Steve has to say here. It's great having all this talk about technology, but most of us don't want to build an iPhone to communicate. The same with running a railroad. It's more of when would it be plug and play. I think that goes to what you were saying, John, earlier. You don't want to get down into the electronics or into the programming. You just want to get that thing in a box, put it on the layout, screw it in, put the power in it, plug your deal into it, and you're good to go. Right?
Right. And so it sounds like with the comment from Dave when you chimed in, our friend Dave Falkenburg, who, hey, just magically appeared.
You just summoned the demon.
Don't like that.
I can't complain about what took so long, other than it has to do with my day job. So
the pesky billing, paying the bills. Yeah, so like Dave said a little while ago over text, the MQTT stuff's not really off the shelf, but companies like Seth's company or RR Circuits, Digitrax, NCE, they all make boards that plug into your DCC bus or LocoNet or something like that, and you can wire up buttons, switches, whatever you need to do, and then you're good to go there. It's, you got to put a little bit of work into connecting it all, but otherwise you don't have to worry about programming or defining things, especially anything that most of these products have some sort of file within JMRI where it just becomes a drop-down menu and you fill out some boxes like Seth talked about, and there you go.
Yeah, it's really not. It's not complicated technically. It is not very discoverable or usable for normal humans. So in an ideal world, we might do better to have boxes that, Lionel actually was doing all this stuff for toy trains with, I think it's their Lion Chief Bluetooth system. So basically things would automatically configure. You didn't have to program things. You plugged the switch in and it was immediately discoverable. And then, but it's a whole bunch of software to write about how you interconnect things, how you snap them together.
Well, ESU has that, right? Their modules and systems. I know if you have an ESU command station, you put a loco on the track with an ESU decoder, it broadcasts out over the track to the command station and it talks to it.
ESU has an extension of DCC. So and it's what their loc programmer uses. They have a much higher speed interface that when their locomotive and their command station, and their loc programmer is an example of a low power command station, they switch. They basically do a little dance and say, oh, you're ESU, I'm ESU. We're going to go a million miles an hour and we're going to be able to do stuff that DCC can only dream about. It's one of the things that can happen if you go proprietary, but it's really hard to do that in a standards-based world, and not everybody wants to share their secret sauce, right?
I'm looking at you, MTH. I'm looking at you.
They're going to be there, and Lionel actually had a technology office that was local, and they were doing some very amazing stuff. And they were actually I don't think the office exists anymore, but about 5 years ago, they came and talked to us because they were trying to build a lot of stuff based on iPad and Android tablets and things. But all these things are typically advanced developments. Dave Reese of Blue Rail Systems negotiated. What happens is these big vendors come in, because I think it was a couple of years ago, Blue Rail Trains did a demo, right? And they're using a Bluetooth chip to do everything. One of the interesting things there is it uses Bluetooth. So everything already has a unique address. So there's no address conflicts. You can't, my Boston and Maine RS3 has the same 128-bit magic secret identifier that's unique in the world. A lot like some of the technology in LCC, as I've lost everybody on the call. Unique identifiers are one way, so that you don't ever have to program something. Everything is defined to be something that is not duplicated. And once you do that, you know that you're always unambiguously talking to Dave's Boston and Maine RS3, and no one needs to keep track of that because there's only one of those in the universe.
Right.
So and LCC uses that technology for events. So theoretically, everybody's layout in the whole world could be plugged together on a giant Fremo layout with long haul trunks, and there's design in LCC to support that. Not that anybody will use it, but it's, geeks are going to geek, right? There's
Very
overkill,
much so.
maximum overkill whenever possible. But what really needs to happen, it'd be really awesome if you had like Cato Unitrack and you snap it all together, and like every piece of Unitrack had a block detector in it, and every switch had a detector in it, and also had the actuator. And there's nothing that says you couldn't have something that ran over the rails and did all that and automatically figured out the topology of everything plugged together. That's like the holy grail, right? You snap together the train set on the floor, and all of a sudden your iPad in the same room has your train layout there. And then as you put your trains down on the tracks, they know where they all are because every section of track has detection on it. And it's accessible to do that. The technology is there. It is a mountain of work to make that technology accessible to mere humans.
When are you retiring, Dave?
The key is that's not
see the future.
I need a CTO, Dave.
So you can.
Vision is open.
To Andy's, yeah, I know. I got this day job. A lot of you are carrying around products that I worked on in your pockets, and I need to make sure that they don't, that they last all day long and they don't explode, and they mostly work. Always work. Always have to say always work. Mostly work is the pragmatist in me. Railcom is something that could work. That's the two-way DCC stuff that's way more popular in Europe than it is in the US. There are electrical reasons. US layouts tend to be basement empires or big, whereas and Railcom requires very much. It doesn't scale well to like a scale mile of track, right? Where these guys with giant basement empires or giant club layouts in the US, it's different. You have you could have a 20-foot long block on Railroad Club in the US and a 20-foot long section of track, maybe in a Fremo layout in Europe, but probably not in a home layout. So Railcom is really nice. So.
Oh, here we go. Yeah, there's a question: how to find out about this MQTT? Is there some website like mqtt.org or something? Or
there are a bunch of websites. It's used. So MQTT, like I think Seth said at the beginning, it was originally designed by like some folks at IBM for doing telemetry on like the Alaska oil pipeline or things like that. So the idea is that you needed to monitor pressure on some giant pipeline. It kind of was when the capital I internet was around, right? But it didn't even work on the internet at first. It ran off serial links. So it's a industrial control, long distance, over designed thing that has now been co-opted into running a lot of interesting things. So when Amazon did their Amazon buttons and did a home automation stuff with Alexa, they taught everybody to do things based on using MQTT. So Amazon has giant MQTT servers that they charge you per microtransaction for if you're a light switch vendor or you're a person that wants to ship someone Tide Pods, right? So there's, those little things, those little buttons, they used to have these AWS buttons, they were called. They were a coin cell battery, one of these ESP chips, and a button. And the thought is that you would press a button and it would say like, send me more of laundry detergent, send me more toilet paper. And then you like, you get it so cheap that now all of a sudden, like my printer, I just had to buy a new printer after 21 years. My printer was older than my son. Now my printer will reach out over the internet when it's running out of toner, and it will send a text message to one of our phones and say, hey, I'm running low on toner. Click this button to get me to buy more toner direct from the manufacturer for more money than God.
For
right?
more money than the printer.
Yes, for more money than the printer. Yes, a black toner cartridge is $80. So, yeah.
Wow.
So half of the price of the printer is the first replacement toner cartridge. But all this technology exists, and so anyway, getting to the question, there are, if you Google MQTT, there are open source things. There's an open source broker, or called the server, also called Mosquito. And all of those things exist. The majority of the people using MQTT out in the hobby computing space are using it with a tool called Home Assistant, which is a system of connecting things up. So a lot of people are using these ESP32s and ESP8266s and all this cheap stuff to go do stuff. Some of the stuff you buy at Home Depot with the smart light switches is built out of the same stuff.
Is that the thing Seth was holding up earlier, that little chip?
Yeah. Did you have a Wemos or something?
Yeah,
there were
Wemos.
Wemos.cc.
I think it was a Wemos D, but you know, it's essentially
D1, I think, probably.
Yeah.
So Google MQTT software or Google MQTT tutorial. You'll be weirded out because it's not train stuff. It's all like talking to MQTT from Python, talking to MQTT from JavaScript, talking to Mosquito through Java Beans. You know, it's all crazy. There are a lot of them. Everybody, because it's out there. You know, it's very pervasive.
So I now that we have Dave, Bernhard, and Ray, who are all members of Silicon Valley Lines, I'd like to come back to a question or a thought I had earlier. Your club is 100% touchscreens now. Yep. For turnouts and maybe some other widgets like the turntable. How does that work versus when you had some physical push buttons? Are there any real pros and cons? Because I've considered implementing some touchscreens at our club where we're still all analog push buttons. Just because I can wire fewer things, but I'm wondering. I understand that your particular solution is somewhat homegrown, so it's not quite apples to if I was using Panel Pro JMRI. But you know how did that? I mean, outside of just the overall evolution of it, how did it go when you basically ripped off the Band-Aid and took out all the buttons?
It predates the JMRI panel sharing on the web by almost 5 years. There was a time when innovation in JMRI was held up due to a bunch of lawsuits.
Yeah.
And so we would do prototyping and we wouldn't share it with the world because, hey, it was weird. We didn't want to be sucked into a lawsuit. And so we were playing around with point of sale system touchscreens, Linux servers. We were not even using JMRI because we were worried about being pulled into that crazy lawsuit. And I think in about summer of 2008, we had our point of sale terminals talking to our Linux box, throwing turnouts on our NCE system, all homegrown. And Bob Jacobson came down as part of the Bay Rails event. And we gave him a little technology demo. And we talked about how we did it. And I said, it sure would be cool if JMRI did this, so we didn't have to maintain this. And then one of the guys who built that first system left town because technology / reorgs at HP. And then we, in about 2012, we reconstituted the whole thing again using a completely different backend because I was working in a group and had some spare time and had some other people who then decided, oh, let's just make this all over again because it'll be cleaner. But now JMRI does everything that we did kind of homegrown. So sharing a pro panel on a web via a web server is effectively what we're doing. We just happen to do it all with stone knives and bear skins, right? Coding it all up and sending smoke signals to the NCE system. So the way it works is actually pretty cool. You basically, if you can figure out how to build a panel in JMRI, which is probably the hardest part because the UI is not intuitive per se. It's okay. Panel Pro layout editor is different because of course those are two different things, and knowing how to overlay a signal system, all that, it's very complicated because it is an open source project. There have been many hands in it, and there has not been centralized coordination. So it's complicated, and everything that was ever going on with model railroad software, because JMRI won the lawsuit, everything that was open source related to all this stuff ended up in JMRI, so that it was covered by a blanket of not being sued. So anyway, but getting to answer the question, that maintaining the tablet hardware has been okay. The biggest thing we have to put up with is when the panels we put in 5 years ago stop running the latest operating system. Then they get out of sync. So if you're using a small number of panels and they're not like the first version of the iPad that Apple shipped that doesn't speak all the web protocols that the latest panels speak, it's fairly straightforward. We have all the problems that any sort of server side thing happens when someone updates the operating system or someone updates JMRI or somebody updates the server. We have like a Mac Mini running everything down at the club. When someone changes any of the software versions, we basically have to have an informal IT group make sure that everything still works. And we don't, it's all spare time, right? So it's so the worst possible case is some random member of the club comes in, updates the software because everybody knows the password, even people that shouldn't know it. And then breaks the system because it's software. There's like 3 different versions of software that all have to combine. So if you have software people in your club that are not taxed, then it's doable. I know, Bernhard, you're the guy trying to figure it all out when no one else is around too.
Well, my task for the next few weeks is to update JMRI. And when people update JMRI, it's not like they do this because they want to annoy anybody else. They do it for a good reason, like current decoder files or what have you. So we had that a couple times, and by now everybody understands that no, that's a bad idea. Don't do that. Just ask someone else. My task ahead of me is pretty much update JMRI. Check with all the tablets that we have at the club, the various generations, what still works, what doesn't work. Likely it's all going to break because the APIs have moved on, libraries have moved to newer versions. So it's going to be fun to to make it all work again, but it's doable. The one thing that we haven't talked about yet with the panels, with the web panels, is when we had the hardwired push button panels, they were pretty close to the turnouts that you were controlling. With the web panel, with the tablets, I mean, those tablets cost money. It's not like we put tablets in every location where we had a push button panel, but we consolidate that a little bit. There's instead of, say, in one aisle, instead of having 6 hardboard panels, we have 2 tablets. And occasionally it happens that in that aisle you have multiple operators. It's a double-deck layout that all need to line switches, and they're switching there. And there are only 2 panels or 2 tablets to do this on. So you have a little bit a possibility that there is a traffic jam in front of the control panel. So placement of panels or of the tablets related to where people normally do switching comes as an additional consideration for layout design at that point. Similarly to don't put 2 switching areas on top of each other. But it's just one more of those things. It worked. So from the membership's perspective, I think, and admittedly I'm biased, I think it worked out really well. Everybody understands how to use the tablets. You just touch the turnout instead of pushing a button. It's very accessible. We have a couple locations where the virtual panel is very packed with a lot of turnouts because that location is very complicated. But aside from that, it works really well.
You know what I'm hearing, guys? I'm hearing that when it's all figured out and it's all working, it's miraculous. It's wonderful. when something happens to you, you need an IT department to figure out what the hell's going on.
If you're in a club,
mortals need not apply.
Right? So for a club like SVL, you have your IT department kind of built in because most of the members, if not all the members, are in high tech here in Silicon Valley. So it's kind of like a double-edged sword, isn't it?
It is, and John's point from earlier is well taken. You really want to have this plug and play, configure it. Ideally, not even configure it. Just have the whole thing work automatically and do the magic, and that's how it should work. We're totally not there yet, but it gives a direction on for where this thing could go a couple of years down the road.
Sure. There's a question that popped up that's for Ray. Someone's curious about the control system for your radio controls.
Well, what I'm using now for all my engines is Aristocraft Revolution. Now, Aristocraft went out of business 4 or 5 years ago, but the electronics end of the business was sold off to the guy who ran it basically for Aristocraft anyway. So there's still support available and equipment available. It runs at 2.4 gigahertz, if anybody cares. It uses a standard cell phone and Wi-Fi channels. That's not exactly, I'm not sure if that's what the person was interested in. I looked at dead rail systems for HO about a year ago, I guess. And I think Tam Valley made one, and there's one called Blue Rail. And there's probably a half a dozen at that time companies that were coming out with or almost coming out with stuff that used one technology or another. But there was nothing like any kind of standard.
Is that AccuRail stuff like a competitor to AirWire? Is it that same component, or is it something else?
Aristocraft?
Oh, Aristocraft, yeah.
Yeah, AirWire. AirWire also makes a battery radio control system for large scale and small scale.
What about using MRC Wi-Fi system? I'm not familiar with the MRC Wi-Fi system.
I'm not familiar with it either.
So both Digitrax and MRC have plug-on systems now that let you control using a phone. So they have a Wi-Fi setup with Y throttle on the iPhone and iOS and engine driver from Android. And so for people that don't want to have a computer or a laptop plugged into their DCC system, they have a box that plugs in. There's also something for NCE called Wi-Fi Tracks that does the same thing. You plug it into the cab bus like a throttle, and then it works that way. So there, I think Digitrax is the LNWI, the MRC system. I'm not familiar with the brand, with the naming, the branding of it, but it basically puts one of those Wi-Fi chips into your DCC system. It's an external box.
Okay, but it's still DCC on the rails. I
Correct.
thought the Wi-Fi Tracks guy actually had a Wi-Fi decoder in the locomotive.
He does. He has a couple different systems. So if you think about what the Wi-Fi track system is, what a Wi-Fi decoder is something that talks on one side on Wi-Fi and talks to a motor or DCC system on the other side. And so he has a version that plugs into and acts as a decoder board, right? So it can go inside, so it hooks directly to the motor, and then you use engine driver to talk to your locomotive over Wi-Fi, right?
Right.
And then he has systems that plug into NCE because he discovered that there were people wanting to do that. I think NCE was looking at that for a little while and decided to not pursue that right away. The Proto Throttle guys have a board that does the similar thing. That is actually a whole area of technology that's really awesome. It's super complicated on the inside as well, but building and using all this technology to do like physics modeling of the locomotives and having reverser arms and independent brakes and train brakes and the little miniature control stand. There's a whole complicated mess of software running in there. There's a whole different proprietary wireless module running that whole thing too. So, and that's actually open source. So there's even a guy who's supposed to be doing a Steam backhead version of that throttle down in Australia or New Zealand.
It's Mark
He's in our chat.
Yeah. Cool.
Yeah, Mark Stafford. He's in our chat, or was in our chat. I don't know if he's still here, but I saw him earlier.
This is a whole thing. Most of the people that I know who use proto throttles are not techno nerds. Like people doing control systems or building their own control panels or putting in a signal system are either nerds or they're paying nerds to do it. And
that's true.
So
a large percentage of them are actually put in by a relatively small number of people who advise or are, quite literally contracting with people to do it.
Hey,
Mark Stafford is here. Yeah.
Hey, Mark.
I'd like to take a time out for just 1 second and make sure people understand that, Dave, you are a nerd and you're not using the term nerd as a bad thing.
I am not. It is a badge of honor.
Right.
Just like geek, it's not a derogatory term for me. If you're offended by that, I am truly sorry. I do not mean it's a term of endearment.
Yeah. Right.
I'm not only the head of the Rail Nerd Society, I'm also a customer.
I like the product so much I bought the company.
Right.
Exactly.
We have a get together that we do on Tuesdays. Dave and Seth and a couple other guys, and these guys start talking about stuff that goes so quickly over my head, and I'm just like, oh, they're nerding out again, but it's not meant in a bad way ever.
Yeah, there's another guy who's not on this call that is doing his own MQTT system. He has emulated the Union Switch and Signal code line between CTC systems, between field units and field units in relay boxes and CTC panels. And it's a guy named John Plocker who runs a website called SP Coast, which is a collection of all of his hobby projects.
John John's a regular contributor to MRCS products, and yeah, I
I'm a
mean,
nerd.
think about it. He is modeling signals down at the code line level.
Yeah. He has MQTT signals defined as what the union switch and signal code packet is. One of his neighbors happened to work for the railroad, and so John inadvertently was showing him his train layout, and the guy who what used to be his neighbor, he moved out, used to work for Caltrans as a signal maintainer, and they had a particularly problematic signal that was not too far from the Santa Clara Depot that would occasionally flash instead of going solid red. And John and this guy were shooting the crap in John's layout room, and John was demoing all this stuff, and he talked about, well, yeah, sometimes you can have this problem where it says it's red and then it's not red, and then it says it's red and it's not red. And the guy glazed over for a second as he realized what was going on the real railroad, and made the repair on the real railroad the next week, and then somehow a large signal showed up in John's garage as a thank you present because there was a broken signal because there was a bad capacitor in it, and he said, well, this was going to get junked, so but that thing you told me about, that was the same thing that happened on the railroad. And the dangerous crazy thing is a flashing red is not a go into emergency, it's a hey, pay attention, right? And
Very dangerous.
And passenger trains run on those tracks, and that, yeah, it's just crazy. So, you know.
Yeah, flashing red on the railroad is not the same as a flashing red on the road where you stop for it. It's a proceed at restricted speed, right?
No.
Right, because flashing isn't as solid as a solid red. So if solid red is an absolute stop and stay, flashing red means, yeah, slow down to a California rolling stop.
It's a mall stop sign, as we used to say back in Michigan. It's not on an actual road. You're not going to get a ticket when you roll through it, but yeah.
Or you might get the mall cop chasing you in his golf cart.
Yeah, that's always to be taken very seriously by people, I'm sure.
Yeah.
Wow. All right. Well, hey, we're coming down toward our regular stop here in a few minutes. So I'd like to, couple things. I want to ask the audience that's in the live chat here if they have any other questions or comments or topics they want to hear discussed here. And the other thing is for you guys, we talked beforehand because I knew this was going to turn into, it's a huge topic. I mean, you could talk about technology and we haven't even scratched the surface of what could be talked about. So if you guys are okay going longer and if we still have questions, I'm okay to keep the stream open. It's up to you.
Yeah, fine by me.
You having fun?
Works for me. Yeah.
So what we'll do is I'll check in with everybody, 15 minutes after we're supposed to stop, and we can decide what to do at that point. But we will stop at what time is it now? 5:23 here. We'll stop at 6 no matter what. So here's a question that someone just put in. Can you guys see this? I don't even know what that says.
That's a Bernhard question.
So Andy is talking about an ESP32 CAN module. This looks like this. Let me hold this a little bit closer to the camera. There you go.
I'd like to try to make it bigger. Hang on a second. Let me see if I can do that. I don't know how to make this. I don't know how to tell it.
So it's a board. It's just printed circuit board with a little flappy camera on top. So you can put this into an HO locomotive, hook up some power wires, and this thing comes with Wi-Fi built in and all that good stuff.
And that's a camera on it, Bernhard?
That flappy thing is a camera.
Okay. Got it.
Yeah. And so what Andy was talking about, he put this thing into a passenger train, and the way these things stream is a little bit different, or the way it streams video is different than what Silicon Valley Lines does with our standard Raspberry Pi based cameras, which look like this. Some of you might have seen this before. There's a camera on the front, same flappy camera, by the way, and then there is a Raspberry Pi down here and the battery board.
Quick question, Bernhard.
Yes.
Is this the same thing, the same device that you showed on the Model Railroading 101 video that we did?
This is exactly the same device that we talked about in the Model Railroading 1 video from last fall. Yes.
Okay. Just checking.
Yep. And so basically, Andy's saying, "Hey, I want to put this Raspberry Pi board into my passenger train instead of this this microcontroller board because it works differently," which makes sense. The catch is that the Raspberry Pi board is much larger than the CAM32. So, I mean, if you compare this is the Raspberry Pi one. This is the CAM30 or the ESP32 CAM. The difference is significant.
But so they do the same. They do the same thing, though.
Pretty much.
Huh.
The only the rest. This guy here has a battery control board for lithium-ion batteries built in as well. So for this guy, you somehow need to figure out the power supply. So that goes on top.
Oh.
There you go. Question for Bernhard.
Yeah.
What did you just talk about? Yeah.
Yeah. So I have this thing. This is the ESP32 CAM. I want to put this into a caboose and have the camera look out through the cupola over the top of the roofs. That probably works. I haven't built that yet. But that fits into an Edge O scale car. Should fit just fine. So that's an ESP32-CAM. That's this module that we talked about earlier. Otherwise, in a cab car, you have space, since you can just rip out the seats and put the larger Raspberry Pi into that as well. That has a Raspberry Pi spy cam in front. That also works.
There are other people who use. I saw a guy actually maybe 2 weeks ago. Mark. Remember Mark from the Primo modular discussion? He has a little. Yeah, Mark Watson, right?
Oh, Watson,
from Nebraska. So he has a DJI gimbal. So there is a very, very small 4K camera that's a couple $100 that would fit actually on an N-scale flat car, and also does Wi-Fi broadcasting. And he was playing with that on N-scale. So he had it on a TOFC flat car, pushing it around his Primo modules. So this is even possible to do in N-scale, not cheap.
So Dave Hammer actually had a great comment that briefly popped up there. What do you do with the video signal? So either one of those devices puts a video stream out over Wi-Fi. And all you need to show that video stream is a browser that is dialed into to the IP address of those things there over Wi-Fi, and then you connect that browser, whether that's running on a Raspberry Pi or it's running on a laptop or whatever. You could connect that to the TV, and you show the feed that way. That's probably the easiest way of doing it.
Wow. There's another comment from Andy.
Oh yes, this refers to little wiggly camera. This is really short.
Mm-hmm. Yeah, it's just on the board, isn't it?
It's just basically sitting on top of the board. You can mount it vertically. I think for for a Caltrain style gallery car, it's probably just fine to get that on the upper deck. But otherwise, yeah, just extend the wire for the camera and fit the camera wherever you want to put it and put the board somewhere else.
There's a bunch of there's a remote railroad operations group on Facebook that is fairly active with folks in this, playing with camera cars, playing with all sorts of things. Yeah, there's whole other bits. I don't know, what you guys were talking about when I was fumbling around, and not around. There's other parts of technology, like we spend an inordinate amount of time messing with computers to make our operations work. You have a whole computer simulation that drives the work orders and the waybills that get used on our club layout and generate the switch lists. I know Ray uses JMRI, right?
Yeah.
Yeah.
Yeah, we did a whole unit on that on a Model Railroading 101 video that was about JMRI, where Ray showed us his switch list generators on JMRI. It was a very cool program.
Yeah, JMRI operations is really cool.
And it works really well. It generates all the switch lists for our operations group outside.
Right. The coolest thing about it that I remember was when we were done with an op session, it took you only about 5 minutes or 10 minutes to come out with a whole new set of switch lists, which was pretty convenient.
Yeah. If everybody moves the cars the way they're supposed to, then you just say the train terminated, generate the next one.
There's always that caveat that someone won't mess up.
Yeah, John.
What do you mean that's not where that's supposed to go?
Yeah. I mean, it fits. It fit on the siding. What did I do wrong?
That's completely prototypical.
Run out of time. We'll just throw it over here.
Robert Bowditch said his father used to work for the Western Pacific, and one of the jobs was driving around making sure that the things got delivered to the right place. Because people would call you up and say, like, hey, I paid you. Where the hell's my shipment? And and they'd look at the paperwork and say, well, that train already dropped off that boxcar. And so occasionally a boxcar would be in the wrong place, and then they'd have to get somebody to go out and move it to the right place.
It's the original precision scheduled railroading.
Oh yeah.
Oh, that's great. So I'm kind of curious. Dave dropped off here. I don't know what happened, but what's this?
No, dude, it was just pizza logistics for later.
Oh, well, that's important. You got to have your. Yeah, you
have to manage the latency of the pizza place that gets pounded every weekend evening, and you have to predict that you're going to want to eat pizza anywhere between 45 minutes before you're hungry and an hour and a half before you're hungry. But if you wait until 6 o'clock, then you're definitely waiting an hour and a half. But if you do it at 5:30, you're definitely getting the pizza by 6.
You need one of those Amazon buttons for that.
Yeah, give me my pizza. Yeah,
a pizza button.
That's right. There's an ESP project for you.
It would probably sell virally too.
Well, they would just give you one. You buy 5 pizzas and you get the button.
Well, and when your 3-year-old whacks it like 8 times in a row.
That's the dangerous thing about
your neighbors are getting pizza.
Yeah.
Someone was commenting about linking. I saw it.
RFID and JMRI ops.
Yes.
Seth?
Way.
Well, he said in the comment, he says to lick RFID, but I'm pretty sure he meant to link it.
I think he meant to link.
Yes.
Lick it might be a little more fun. Hey.
Yeah.
Well, if you're the chip, I don't know.
Yeah, so, people have done it. My RFID system actually just generates switch lists because that was all the clerk on my layout really cared about. But my friend Steve Davis took my readers and wrote an interface to JMRI, and it's very nice. You sit at his yard in Heavener, Oklahoma, I think, and train comes in, and it has a tablet mounted, and it tells you, as you pull over the reader, okay, the next car goes to track 1, the one after that goes to track 3, and it's all sorted out for you. Now, I said to him, well, this is wonderful, but why don't you just throw the switch? He said, well, my yard masters thought that was boring. So, but yeah, that works. And also people have done things with what are called reporters in JMRI, going back into a deep dive into the software weeds in JMRI. But there's a couple of ways to do it, and it certainly works well.
Something that we were talking recently, Seth, I think it was one of our Taco Tuesday lunches, and I was listening to, I think it was to you and Plocker talking about something. And I say something because I didn't pick up all of it. But what I did pick up was that you were using basically what the real railroads do, but you're compressing it, there's that word compression again, into a model application,
yes,
which I thought was really cool. And to understand how big railroads actually work can help you if you're trying to replicate that on a layout, just by coming up with those same, because they've already dealt with all these problems. How did they solve it? It's
right,
doing all the work for you.
They have a big tag each, on opposite corners of the car, and it's kind of like this, say 6 inches long and 3 inches high and maybe an inch thick. And I have one when I do the clinic on it that I pass around. Ours are, of course, the same size as the ones that you put under your pet's skin, and we refer to them informally as kitty chips. Although the actual medical grade ones don't work, ask me how I know, for our purpose. But, I've always had visions of, my cat at the time, Moki, jumping up on the layout and triggering the reader, but she didn't.
But your example is actually a good example for another one of those cases where the use outside of model railroading enables you to use this technology in model railroading. Like if someone were to design RFID tags just for the model railroading market, they would be unbelievably expensive and not useful. But since there's so much demand out there, we can use those tags and we buy them really cheap and then stick them on every car and combine that with your reader. And so
that's right,
have the tracking that way.
Yeah, exactly. And it's a commodity thing you can buy, from any number of suppliers and on Alibaba or some similar marketplace. And, so they get pretty affordable.
There's some really interesting stuff that a guy back east is doing with NFC. So NFC is near field communication. So it's the things that show up in kind of, they're like RFIDs, except, there they are. They show up in price tags and retail tracking. But it also shows up when you do your contactless payments with your phone at your credit card terminal. And so now everybody's phone has one of those NFC reader writer things in it. And so you could imagine at some point, like, where the heck is that car going? And then pull out your phone, stick it on the car, and your car goes blip, and it says, oh, that car's going to so-and-so.
Hey, Dave, that's proprietary new product research. No, seriously.
Okay, yeah.
One of those. And the great thing about that is, you can just use your phone as a wand, and, it'd certainly be practical to build a little application that just created a switch list on the fly on your phone.
Yeah. I mean, the cool thing here is, right, that there's a lot of technology that gets designed for something, and it can end up getting used in model railroading, and that ends up making things inexpensive. If something starts out in model railroading and then gets used in the rest of the world, well, yeah, that's a little different.
When has that ever happened?
Actually, a couple of model railroad simulation programs have been picked up by the real railroads.
Oh, interesting.
BNSF's training simulator system started out as a model railroad product.
Interesting.
Didn't know that.
Yeah.
So Bernard, how come SVL doesn't have RFID tags on the 800 or so cars you guys have down there?
800.
Well, 800 that aren't bad ordered, right? Not including the mega drawer.
Yes, exactly. Which by the way, is also a great example for using a linear actuator for moving a drawer. And I think that linear actuator was designed for a rolling shutter or something like that.
Either a window system or a sliding gate.
Yeah, right.
Yeah, but that thing is like all relay logic, right? I mean, that's like, dark art voodoo, does that run on Fortran? I mean, geez.
Defense against dark language.
Who left in the club can troubleshoot that?
The guy who did that moved out of the area, so if it breaks, it gets rebuilt. Because that's how engineering works in the valley. If you can't figure it out, sometimes it's cheaper to build a new system.
Yeah, and then we just stick a whole bunch of electronics in it.
Yep.
That comment.
I'm looking at this window here, and Joey asks a good question.
Yeah.
Well, is it growing? The question is really how fast is it changing, not how fast is it growing. Obsolescence really is, does it still work for you? So you can have a product based on fairly old technology, and if it still meets the challenge and you can still get parts to repair it when it breaks and the guy who designed it hasn't moved out of the valley, it's not obsolete. So, within pretty broad range, not all that fast. The rate limiting thing for big stuff like locomotive decoders, and by big I mean big market stuff, is it turns out the distribution model kind of says you have to have ready to run locomotives. So, until you can get a couple of million locomotives out there, that technology is not going anywhere. And somebody has to make a market for a couple of million new locomotives while people are still selling the old ones. So my guess is it's not happening.
Well, yeah, I mean, DCC is more, specifically into sound decoders, or maybe 15 plus. But you look at how far sound decoders have even come recently. I know with some of the scale trains models that have, they have a decoder plus a daughter board to enable, 16 something outputs on that turbine they did. So it's an old technology, but they're still getting more and more out of it, it seems.
Yes.
Yeah, and if you want to see what the future holds, Nordell Drew was on a podcast the other day with Shane from Scale Trains, and they were pushing really hard for adding even more tech.
Oh, really?
Well, yeah,
the younger kids want even more tech inside the engines ready to run. But with that, I have to go. So I have to do that pizza pipelining order thing. So.
Thanks for coming, Dave. Appreciate it.
All right,
Dave.
no worries.
Bye.
Bye, Dave.
Yeah,
Pizza
scale trains have, they have that frog clank sound, and it uses like a little wire on the underside of the truck or something to sense that. That's impressive.
That is pretty cool. One of the things that I've been really impressed by is how the manufacturers are putting together the inside of, all the electronics and stuff. Like when you take the shell off, it's not connected with wires anymore. There's these little tabs or little, I don't know what you call them. I guess they're tabs that push down onto contacts onto the body portion, or the, what do you want to call it? The chassis. So the shell has little male tabs, the chassis has flat tabs, and just by contact, it makes all the connections. I think that's pretty cool.
Yeah, modern CAD systems are phenomenally good at working things out. Use Fusion 360 or something, and you think it's mostly about mechanical design, or it's mostly about electronics, but it's kind of doing both. And you can figure out, how high your circuit board's going to be and where it needs to interface with the mechanical stuff that's holding it. And you could be designing your locomotive shell and the other piece. And when you're done, it all fits together. So there are some fantastic design tools that we're, blessed with today that make really trick things like you're describing, John, work.
Yeah. And I guess that's using technology to improve model railroading yet again.
For sure.
I will tell you, Seth, on that line, though, it is amazing how some manufacturers that I'll leave unnamed, when you open up their engine, they're decidedly not doing that.
Yeah.
And when you have to fix it, like
barely graduated from incandescent light bulbs, and it's still a rat's nest when you open it up.
Yeah, major manufacturers producing sound locomotives, and you have 3 LEDs like all wired together. It's like, wait, what?
Well, I don't.
We still have O-scalers, there's ironmongers out there,
That's true. My decoder is not going to weld anything.
Maybe when we're not on the show, you could let me know, because I'd like to avoid that one if any way possible. Well, that's great, though. But I don't know. I'm trying to remember. I think a Rapido locomotive was the first one I ever opened up where I saw that contact system I was talking about, and it was just slick.
Yeah. Well, Jason's very savvy, and he's a new generation of manufacturer and really got into it, well informed by what you could do with this stuff, and and he's done a super job with, in many cases, some fairly obscure prototypes, and and it sells. So good for him.
Yeah, sure.
I've definitely actually pre-ordered some things that I have no need for whatsoever, but I love what they're doing so much. I just want to support the company, I'd like to see them continue to grow. Yeah,
exactly. I mean, it's just, exactly. I've bought stuff from him just because it's cool. And then, he came out with that GMD1, and I have a friend up in Saskatoon who models Canadian National branch lines. And I saw him at a train show, at a national convention, and he's walking out there with a box of a dozen of them. So this is, easily $3,000 Canadian worth of locomotives, maybe 5,000.
Now, here's an interesting question. To be honest, I'm not sure if I understand it, but maybe you guys do.
Oh, well, I've talked to Mark about this before, and what he's really trying to do is pretty cutting edge. We were talking earlier about the proto throttle, and Mark's the guy who was trying to build a steam proto throttle, which the manufacturers actually decided is too much, but Mark is pushing forward and extending the limits. So the issue is I'm trying to model the response of a steam locomotive, and I want the stack torque to be correct for the load the locomotive is pulling. I think that's what he's driving at here. So you need to understand the back EMF, how hard the locomotive is pulling, how fast it's going, and then model what that's going to sound like and tell the sound to make the right sounds. And I mean, wouldn't it be cool to see your, K27 barking its way up to Osier or, whichever, your favorite narrow gauge summit is. And it would be. It's very cool. It's a hard problem. That's why they haven't done it.
I thought that Soundtrax has something like that, where if the load's heavier, it stresses the certain sounds more. I don't know how it works.
They do. I mean, they're looking at the back EMF. You can see what's coming back to you during the quiet part of the pulse. This is actually technology that was developed for electronic countermeasures. So you find your locomotive is causing the Russians to think your plane is 50 miles from where it is. It's pretty cool stuff, and it's well understood at this point. May still be classified, but anyway. But the trick is to synchronize that properly with a prototypical steam backhead, so the controls look and feel like the steam. And there's what was Dave calling it? Dark art.
Yeah. Well, hey, we're getting down to about the last 10 minutes or so. So if there's anybody with another question, or maybe someone on the panel, if there's something that you wanted to talk about that we didn't get to talk about yet, maybe we went completely off in the weeds with that MQTT thing. I don't know.
We were totally nerding out for a while. One thing that bugs me occasionally about technology is, especially in model railroading. Model railroading is a hobby, and when stuff doesn't work, I don't want to do my day job during my hobby time.
Right.
I'm spending a lot of time in front of screens, and do I need more time in front of screens? Apparently I do. Otherwise I wouldn't be doing this. But the one thing in particular that I am somewhat ambivalent about is on our web panels, on the tablets where we have the panels at the club. The one thing I really like about these old-style push-button panels is there's actually tactile feedback. You're not working or dealing with a piece of glass, but you're actually feeling that the button goes down and and it comes back out again, and you know where there is this moment where, okay, now it sent the button, or now it sent the signal that something happened or is supposed to happen, because you get that tactile feedback. This is something I personally really enjoy, and that's why on this layout here, I'm actually not using tablets, even though I could. I can control every turnout from a tablet, from a web browser, whatever. But I built these push button panels because I really like this extra manual, old style feedback to it, even though there's a bunch of technology behind it.
Amen, Bernhard. I think that's a. Go ahead, Ray.
I was going to say, you could have used ground throws or push rods if you wanted to go old school.
I could.
Chemical linkages and fishing weights and things, sure.
But remember from the beginning, I built this layout to do automatic running. So fully manual is not what I was trying to do here. I do have direct button or switches that go directly into tortoises on my modules outside of this room, since that module is not meant for automatic running. So made it a little bit cheaper, and I tried out something different. But I really like this tactile feedback that we rarely get with the computer-based stuff.
You know, it's interesting you mentioned that, Bernhard, because I've been running at SBHRS, and I'm looking for a switch on the front of the panel or in a little drawer, whatever. They're hidden sometimes. And I can't find it. So I look on the layout, and it tells me, whatever the number is. I go into my phone, and I type it in, and it throws. But then I'm double checking, like, oh, did it actually throw? And I'm having to look and double check and triple check and make sure. So I understand what you're saying. I get that, because there's it's like invisible magic. If it happens, you have to look, and it worked, But if it's a button and then you hear it after you push it, you hear it, right? So there's more than just one way of telling it to do what you want it to do, or one way to know that it did what it was supposed to do. So I get it.
That's totally true. Again, on my layout, I'm lying to you, because yes, you feel the button being depressed and coming back out, but that doesn't mean that turnout is actually going to move, because the technology can still go wrong.
Sure.
Well, after your comments earlier, Bernhard, about having to be the IT support for all the touchscreen panels, I don't think I'm going to implement those, because I would get all the phone calls.
You already do, John. What's the difference?
I don't need more. I got out of tech support for a reason.
It's a balance in the end. You get a bunch of benefits out of these tablets or the use of technology in general, and I think it makes a lot of sense to use this stuff wherever it helps you get more of this. Gets more of this feeling of being immersed with your model railroad. Wherever that makes sense, totally go the technology route. Do the cool stuff. Like I have routing built into these panels. That would be a gigantic pain in the behind to do in a traditional way, but with JMRI and routes. Yeah, this is easy. So it helps me there. So wherever that makes sense, use the really cool stuff, but don't overdo it. I mean, at SVL, we do everything because we can.
that was a comment.
True.
Yeah, that was a comment that I think Seth made. SVL because we can.
Yes. Yeah. and yeah, if technology fails, do what the real railroads are doing. They also have multiple layers of fallbacks. It can get really tiresome. So the stuff that you're putting in better work.
Oh, here's a good comment. See, now anybody who figures that one out, or the mute button, right? For certain members, you want the mute button. Anybody who figures that one out is going to be rich.
There you go.
All right. So we got like 3 minutes. Anybody else got something to contribute before we start disappearing?
Covered all my bases for today.
Right. Not all at once, please. All right. Well, hey, I want to thank all you guys. It was really fun. You know, some of the stuff like this, I wrote it down. MQTT is kind of going over my head, but I kind of understand what it is now, which is just a step in the right direction, at least. So as James Sutton just posted onto our chat there, thank you, panel. I appreciate all your guys' time and knowledge and willingness to share with the world. That's what we do here. We share all this good stuff with all the wonderful model railroaders out there in YouTube land. So with that, I'll send you each back down to our basement here. Thank you very much, Bernhard. We'll talk to you in a couple of minutes. Okay, Ray, again, thank you. I think maybe sometime in the future we'll have a panel about garden railroading. We could, if you're interested, have you back on to talk about the Mystic Mountain. Thank you for your time. John, it's your turn.
Yes.
Thank you.
You're welcome. Thank you for having me.
Yes, sir. Anytime. And that's all she wrote for you. Bye. Seth, what can I say? We're the only ones left. Thank you for your time. Thank you for your expertise, your humor. It's all appreciated. And I'll talk to you in a couple of minutes.
A pleasure.
All right. And that leaves you with just me now. I know, sad, isn't it? I want to invite everybody to join me for the podcast next weekend, Saturday at 9 a.m. I'm going to have our monthly podcast with all kinds of updates, what I've been up to, stuff that's going on, you know, what we usually talk about. And then also something else I wanted to mention is that on the 17th, so St. Patrick's Day, it's a Wednesday at 4 p.m. Pacific time, I'm going to be joined once again by Michelle Kempema for a live call-in show. So that's something that we're trying to do once a month. And we're going to be soliciting feedback from people about topics and things like that. And I'm going to try to get somebody from our local NMRA chapter to talk about the achievement program, because we talked about that last time, but I didn't feel like I knew enough to really be knowledgeable enough to provide the information that I wanted to provide. So I'm working on that now, and it should be good. So thank you all for watching. Thanks to our live chat moderators and our amazing top secret producer here. And yeah, we'll see you all soon. Thanks for watching.